So I have this really bold topic of my talk, but I have to start with talking a little bit about my feelings. This crowd, you, unfortunately I don't see you, which is pretty good, I think. You are heroes to me. You are also my hope. I think that this talk hopefully will get a few new ideas in your head. But I'm pretty nervous, so if you could just help me. And I'm also so thankful for you staying this late. I know that you have families and other things to take care of. And I hope that this talk can give you some new ideas. So with that said, just a few words about myself. I'm a dad. I'm drinking beer at my couch at home, making apps, and as we heard, a little bit of extra time based on making the school platform in Stockholm better. But for those of you that know me, I'm also having a kind of other type of mission. I'm also trying to kind of get politicians and society to understand the powers that you have and the power that we have with technology to do something better. So this is me in China, talking to a different crowd. But how come I feel more nervous when I talk to you than when I talk on these type of scenes? I think that's because I think you are awesome, but you have power. I know that you have the power to both do good but also do bad. And I think that we have a responsibility to take care of our joint future and not fuck it up. So let's talk about how to save the world with JavaScript. But first, I want to share a few words, and these words are really important to me. These are our values at Iteam, and I'm going to go through them all. Create value, have fun, and do something good. These are the words that I live by every day and that we do at Iteam. And these are the ones that helps us say no to toxic customers. And these are also the words that have led me to different places in the world to talk to the president in Nigeria about why they shouldn't let the digital imperialism, maybe from China or United States, to take over their tech scene. So let's go through them. Create value. From my point of view, creating value seems maybe to all of you like the obvious choice for a company. But value is not the same thing as money. Unfortunately, sometimes you can actually you can actually do sorry. Many times these are not the same. Many times you can have a consultant job and just write crappy code and make a lot of money, but we want to do real value. And real value for us is changing someone's life. Changing someone's life means that we have to understand the users. The next thing is having fun, and this is not about drinking beer after work. but rather we have found that when having fun as a measurement or as a value, we increase our problem-solving skills. And also, laughing means that we also feel more secure. So laughing or having fun is kind of the best litmus test for us to know the state of the team. And if no one is having fun, that probably means that we have some sort of conflict or that someone feels left behind. And also, if we can't talk honestly with our clients, that also means that we're not having fun. So this is a really good way for us to always make sure that we do create value. And the last thing is about doing something good. And as I said before, I think that we as programmers have a lot of power, which means that I think that we have a moral obligation to also do something good. And if any of you have read anything about history, you know that good intentions may not be enough. You can still accidentally make everything a lot worse. And that is why we are constantly working with experiments, different types of experiments, and try to make them as small as possible, and try to have one hypothesis and find out a safe-to-fail experiment. So I'm going to share 4 different types of experiments that we have. And all of them are open source. So in the end, if you take a picture of the last one, you will all be able to also contribute and help out in these 4 experiments. So the format for this part will be, first of all, the problem, how we fucked it up, some analysis of what we can do, and a little bit of starting point for a solution. So, and also, when I say we, I mean us as programmers, not me or we as a company. And if I accidentally say I mean, of course, all the teams and not me myself. So the first one is how we fucked up elections and democracies. And so this is about Facebook and social media. And Facebook was originally like a very good idea, but it started like a small experiment. You all know this for students in Harvard. And the idea was simple. Let's connect people. More communication is always good, right? But what happened instead, accidentally, they built the perfect tool for government and rogue actors to influence whole societies by hacking algorithms or just buying effective ads. So what we did was to create a tool called Floodless Colon. And so this is pretty much quite easy. It looks very, I think, beautiful. But this is just the connections between different persons in Stockholm. So maybe one of these dots are actually one account, and maybe one of them is you. And by just connecting them through a force-directed graph, we was able to visualize how these accounts were connected. And we started seeing different patterns emerging through this animation. And what we also found while doing this was that we had already in Stockholm a botnet that was lurking around within our contacts. And this is unfortunately we don't have this up and running, so I'm not able to show it directly. So this is from another talk, but this is how a botnet looks in this tool. So the reason why this looks different from everything else is that all of these bots are having exactly the same patterns, and that means that they have the same colors, which means that they have done exactly the same amount of interactions during the same time frame. So the yellow botnet that you saw was influencing this social graph that we have in Sweden. And this is Twitter. We also did it for Facebook. And the next problem that we have tried to also experiment with, as we heard in the presentation, is failed public digitalization. Stockholm Stad made a huge procurement almost 10 years ago, and they made a user survey 10 years ago, and then they created a huge procurement for that. But then after the procurement was done, no user was involved in the development process. So that meant that when they launched, of course, what happened was that no one could actually use this, and also they got fined from Integritetsmyndigheten for GDPR data breach. So and they spent 1 billion SEK, which is 100 million euros, on this. So what we did was to create an alternative. And the alternative is quite simple. We just created an app that looks behind the scenes and tries to find the information that we want to show for us as a parent. When we did this, Stockholm didn't know how F12 works in Chrome, so they filed a police report. So which meant that I had me and Johan Öbrink and Erik Hellman, who was joining us very early. We were filed for data hacking breach. So I had 2 police officers in my living room asking me how this had worked. And when they realized, and the police were really professional, so when they understood that the only thing we had done was to open Chrome and press F12 and find the data, they immediately dropped the charges. But Wired picked this up, so they made a 5 pages piece of this. And of course, this is not so good for the city. Yeah, so this is an experiment to also show that it is very possible for a small team to create something that actually is much better. And we got like 4.5 at App Store, and the official app was 1.1. And it turns out that 1.1 is the lowest score you can get, so you can't really go lower. And if you want to have some sort of inspiration, you can definitely go to App Store and look for quite good reviews of the official app. It's really funny. Okay, so that was one of the experiments. Another problem, of course, is climate change, and yeah, how we fucked it up. I think this one is not our fault as developers. I would say maybe that we indirectly are to blame because we haven't done anything enough yet. So, but our analysis is that here in Sweden, transport stands for 30% of all the CO2 emissions. And we are a pretty vast country, so a lot of transports and trucks are going very empty from different places. So what we have done is a digital twin where we can see, and also we built a model or a replica of Sweden in JavaScript, where we can see different examples of how vehicles are going on the road networks, but also making when doing this, we are also having a platform where you can do different types of experiments. So what you see here is an experiment where we tried virtual drones that deliver these packages instead of actual trucks. And the colors here that you can see, those colors are different vendors or different transport companies. And as you can see, they are all going pretty much to the same places. So, but still, they are pretty empty when they arrive, but they are completely empty when they go back in these different areas. So what we are doing now is through this simulation, this model, we can talk to these different vendors and making sure that they do everything they can to optimize their own transport and their own scheduling of their fleet. And our estimate is that we can decrease the CO2 emissions in these rural parts of Sweden with at least 50%. And also at the same time make sure that deliveries are much faster. So, and the service then increases for living in these areas. And as you can see now, this is one truck that goes to Arjeplog, and at the same time you can see all these green dots there. Those are private cars that are picking up their packages from the service points. And still, during this day of the simulation, we still haven't gotten to the most rural parts to the left here in the image. And as you see, we both have the blue company and the red company that still needs to go to those places. So obviously here we have a lot of optimization opportunities. All right, so the last example that I want to share is also on the same topic as we heard earlier on today, which is Internet's becoming more centralized. And the analysis here is that I think that Internet started in the 90s without some crucial part of infrastructure. One of them is identity. The second one is secure payments, and the third one is a safe way to store your own data. And I think these, but we still built everything on top of what we had in the early days of the web, which means what led to email and password instead of a secure way of making sure you have a secure identity. And also you still use the credit cards with the plastic, like text sitting there to do payments. But what we focused on was the safe way to store your own data. And if you just think about this for a while, we do live in the world now where we have a couple of companies that actually controls quite big parts of our lives. And especially since they use the data, we are using their services to also control or to surveil our lives, and that can also have unforeseen consequences for our democracies. So our take on this is to build a tool called Eigendata, and Eigendata is both an app and a digital infrastructure for shifting this way of handling. Instead of services storing a lot of information about users, instead we can envision as users storing all the data from a particular service in some place where we can control it. And instead of having FTPs storing JSON files for us, we are using encryption instead of trust. So basically uses encryption keys to be able to share and also store data. And the first example we're going to do is making sure, and here we are pretty much using the same method that we have already proven with Öppna skolplattformen, which means that we do know that me as a citizen have the right to get this data from the government I have the legal right to share that data to someone else. So we're using kind of that method to legally put the user in control of her data. And the first example we're going to use this for is the job market. And then, of course, there are a lot of different applications for this type of infrastructure. But if we start thinking a little bit about all of these four examples, we can do some sort of analysis. All of them are pretty complex. Not only the solutions are quite complex, but also the problems themselves are quite complex. And if we just talk a little bit about complexity, the nature of complex problems. And the thing is that complex problems don't have kind of an apparent connection between cause and effect. So if you change one thing, you will end up having a completely different problem, which means that and our brains aren't that good at thinking about and solving complex problems. And when we try to solve complex problems, we tend to simplify the problem, and then we go about solving the simplified interpretations of the problem. And this is called simplicity bias. And simplicity bias can lead us to make bad decisions when we are faced with complex problems. And we might try to apply simple solutions to the complex problems, even though that might not work. And we might oversimplify the problem itself, which lead to us missing important details. So to avoid this simplicity bias, we need to be aware of it and try to think about the complex problems in an more open-minded way. And we need to be willing to experiment and learn from our mistakes. And we also need to accept that sometimes there are no simple solutions at all, and that's okay. So I'm going to try to give you some examples from my experience with working a lot with different complex problems, and try to teach you a mindset of thinking about this. One of the things that I tend to think about when visualizing what this is fishing nets. I don't know if any of you have tried to resolve a fishing net. Anyone? Yeah. And have anyone tried to plan how to do it? Have you tried looking at the problem for a long time and just thinking about what can be done? Where should I start? No? Yes, you have. How did it go?
Better than expected.
Okay, but could I maybe you had a plan on having a mindset rather than having a plan on which not to start with? Like when you thought about the plan, did you plan what actions you would take, or rather plan how you had a mindset? Okay, yeah, because the mindset you want to have when you try to solve this type of problem is that you have to start somewhere and you try it, but you can't really try too hard, because then you end up making it worse. So what you need to do is kind of be gentle and just try and try to solve it by just start somewhere and just figure it out. And the same is true for complex problems. You can't really predict the solutions, what solutions that will work and which won't. So you have to keep trying and hope for the best. But also, if you take another type of problem that is not complex, this is pictures from Öresundsbron, or at least what Dali thinks is Öresundsbron. That's a bridge between Sweden and Denmark. And this is an example of a complicated problem where you don't need to try. It would be ridiculous to start trying to build like bridges, small bridges, and just see what's happening. This is a typical complicated problem. We are quite good since the last industrial age to solve this type of problems. We can even put engineers in parallel to just figure this out. On both sides, so, and then at the same time when you're building it, you can parallelize the work a lot. So we are really good at thinking about this and have politicians that understand these type of problems. But unfortunately, the problems we have today aren't complicated; those are complex. So I think this is a mental model that can explain why Stockholm Stad is trying, doing the way that they are doing it. So they spend 10 years of planning and developing, and then they expect launch that everyone loves, and they didn't got quite the reaction they expected. So, but can we have a mental picture for a digital house? So how would a digital house look like? So if we imagine kind of a digital house, how it would look like, because the funny thing is that when we are dealing with digital solutions, we don't have to first understand the whole thing. We actually can build a house where we sell the first apartment in the top floor, and then build the very small elevator and the VVS systems and everything, a very small foundation that supports only this apartment. In the physical world, this wouldn't make sense, but in the digital world, this is actually what's possible. We don't have the same constraints in the digital world as we have in the physical world. So this is why we need to understand kind of that we have the power to do things differently than the previous generation or the previous decisions that was being made. So which means that we can sell this apartment in the top floor. We can actually let family move in, and we can listen to their feedback and fix things that they want fixing. And then we can continue working on fixing those. At the same time, we sell the next build or the next apartment in the same building. And when doing that, we are also increasing kind of the capacity of the foundation, adding a new mailbox. We also, can take when the whole building is finished, we can even add more things on top of the first apartment that we already sold. So I think that this is also one takeaway from me, is that we do have new tools in the digital world, and we don't have to be constrained by the physical limitations we had. And also one important note here is that we could still have an idea of what the end result would look like when we start building the first apartment. But we shouldn't build more than we need on the foundation. Like, we don't need the biggest foundation or the biggest elevators for all different apartments at the first time. But we still need to think about that there might be different apartments coming there. So what I'm trying to say is that you have to do not more, but not less than you actually need for the common grounds. But also when we think about these words and metaphors that we learn in school and that the society is using, but also we have accepted as programmers, we are talking about architecture, foundation, engine, modules, factories. Like, all of those things are constrained by the physical world. So I think that we now are mature enough to start talking about new words. Trying, experimenting, sensing, building, learning, and making also maybe making a fool of ourselves. Because doing experiments in the digital world, we can just often press Command undo or git checkout or just try again. And of course, this is not something new. You all know this. This is called Agile Development. But I think that most of you can agree that Agile has been like a word that has been watered down and now have become, have a fancier name. It's called SAFe in different organizations. And now it's rather means that you have kind of business people, they are talking to the UX people, they're writing specifications, and someone needs to sit together and drink coffee for one day to estimate the time for each part of this plan. And that looks to me more and more like the kind of the bridge building project, rather kind of this digital house building project. So I think that's we need to kind of think about true agile and go back to the real. Yeah, thank you. And I think all of these examples, you have the power to change this, because one thing in all of these things that we have in common is that we have the power to say we don't want that. We'd rather just build something small and continue evolving on that. But also we have to understand that there is, of course, a need to organize. We have the tools to just start creating and start building things, but the business people, they want of course to know something in beforehand. So that's when we have to think about teamwork and how teams work best together. And the best way I know how to organize these type of projects are through open source, or at least an open source culture. People often misunderstand the open source as just being a free way of buying software, or misunderstanding it as being insecure. And both of them are, true in one way, but there are also a lot of different other things that I think is more important when it comes to open source. And the biggest argument for me with open source is that there are potentially more brains working and solving the problems without having to manually organize or plan the work. And when you have an open source software, if you find a bug, most of the time it's easier to just solve the problem yourself and then maybe send a pull request to the maintainer. And this leads to huge benefits in speed, but also that means that you are not alone and you have still full control. So to summarize, we programmers have power, not only to fuck things up, but also make things right. But I think that we need to start thinking in new ways. I think that we need to use new words in order for us to start solving the actual problems we have. And we need to be better at communicating the nature of the problems we try to solve to the stakeholders. And we need to say no when we realize that we are not part of the solution. We need to work together in small increments towards the goals that we have, and to find these safe-to-fail experiments. And I encourage you to find your own values, your own guiding principles, and try to stick with them, because otherwise you might accidentally create new problems for our kids, and they, as if they didn't have enough problems from our generation already. So the last thing I would say is don't worry, be crappy. This is the most, this is how I end every talk that I give. So important. You don't know all the details when you start, and if you force yourself to always know all the details, you will be more safe. It's better to encourage each other to start testing and also failing on stage even. So this is the end slide. If you want to help out in any of these projects, please visit these websites. And that's it for me. Thank you.